Welcome, ladies and gentlemen, here at the Hannover Fair of 2023. I'm happy to introduce the next topic here on stage. We are at the Technical Forum of the Hydrogen and Fuel Cells Europe. You are all invited to have a seat and grab a drink. Drinks, by the way, are on the house. And my next speaker is already on stage. I'm happy to introduce him. He is CEO of the company DiLiCo. Please give a little applause to Maik Heuer. And I also wanted to introduce your topic, not that that falls short. So he's going to talk about the measurement methods for aging analysis in galvanic cells. So the stage is yours.
Okay, thank you very much for the introduction. Yeah, my name is Mike from DiLiCo, from Magdeburg, close to Hanover. And we are developing measurement technologies to control galvanic cells, electrolyzers, fuel cells, redox flow batteries. And I want to show you how can we look into the cell, measure and see how fuel cells and other galvanic cells are aging. You can see it here on the screen. You see the current distribution of a fuel cell during operation. And you can see here very good that this profile is inhomogeneous. And with our measurement technology, you can see at which area your membrane are working and how you can influence by your operating parameters. And you will also see after a couple of hours, 1,000 hours, how this profile will be changed. And then you can see which area of your membrane are aging faster and what happens then in the future. How we do this, I would explain. We developed a segmented board that we integrate between two cells. And this board has several segments. Here we have 209 segments, and in each of these segments we have two sensors integrated, a temperature sensor and a current sensor, to measure then these both values, current and temperature, that you have seen here before. And when you integrated it into the cell, then you can see how good is your membrane working during operation. Yes, and this we connect then to our data acquisition system. You can see on the right side where then all the data are going to our software. You only need a USB port, and then you get all data of the system. Here you can see an example of a fuel cell where we integrated 3 units of this. So you can measure here over the cell area of 3 cells, then this current density and this temperature profile. And here in this system, we integrated 3 units that we also can then measure the profile of the first cell in the middle and also of the last cell, that we also can see this profile distribution over the complete stack, what is also very interesting for our customers. And we developing these test boards for the stacks. It could be a redox flow battery stacks, an electrolyzer stack, or a fuel cell stack. Design it, look what is the best place, also ceilings we regard, and then the customer integrate the system in the cell and then start to measure. Here's an example what you can see when you have the system. On this graph you see the current distribution. It's number 1. This is a black line. These are the stable operation point at nominal point. From the this x-axis shows the normalized channel length of the flow field. Normally the flow field is like a serpentine profile, and I make it in one line here to show you this behavior. And then you can see that there's a fluting zone. This dashed line curve showed that we have, after 0.5 of the normalized channel length, the current density production goes down. There's an degreasing because I have stopped the hydrogen recirculation pump. So there we have temperature changes and the velocity changes of the gases, and then liquid water comes in the bipolar plates and the flow channels. And so new hydrogen cannot go through the membrane, especially after 0.5 of the normalized channel length. And then this area goes down, and you can see before this fluting zone, the gas concentration is higher, and then the current density production in the first area of this flow field are producing more, current because they try to set the output power of the fuel cell at the same level. Yeah, and 1 second later, then it's not showed here on this picture. The fuel cell stopped because no current production was more able at the outpoint of this cell. Yeah, so this device is very good to see or to visualize the behavior of different operating strategies during operation of your membrane. And it's also very good to use it for analyzing aging mechanism during operation. Yeah. You can influence this profile during operation depending on the parameter set, but you will also see that some regions of your membrane will aging and they are not able to come back to the nominal current density from the beginning time. Yeah, so it's an irreversible aging, and then other parts of the membrane try to produce more current density. Okay, and that was all from my side. We also offer CVMs, also to measure the cell voltage of each cell, the current density distribution device I have showed you here, and finally we have also small single-tail test stands for electrolyzer analysis. So we are on booth F34. If you have more questions, please contact me, and then have a good trip home, and see you next year. Thank you very much.
Thank you very much for the nice presentation. So I definitely have questions for you, but maybe the audience does as well. Any questions from the audience? Not right now. Then I want to jump in with a question regarding the thing that you showed us in the end. You were talking about the test stand. Can you tell us a little bit more about that?
Yes, we developed for customer 2 test stands, single-cell test stands for electrolyzer last year. We supplied this last week, this test stands, and there's also our current density measurement device integrated for one of our customers that want to test this electrolyzer membranes, and therefore we developed this test stands. This is a new portfolio of DiLiCo, and so if you are interested, please contact me. We are also doing some things in this way.
Okay, so if you are interested in test stands, go visit them at their booth and learn more about the company, and hopefully you build more test stands.
Yeah.
Thank you very much. It was a pleasure to have you here.
Yeah, okay. Thank you. Bye-bye.
Bye.